for 10.5, which is all about, stretching and compressing. So if we look at number 1, we've got a fun and exciting cube root. So when I plug in -8, I get 2. When I plug in -1, I get 1, 0, 0, 1, -1, and 8, -2. And I can just do this by putting this in my calculator and hit Control-T. I think that's the easiest way to do it. But then we're going to plot our points. We're going to go to the left, -8, up 2. Left, -1, up 1. 0, 0, at least 2. 1, 1, and 8, -2. So we have this, okay? The domain is all real, and the range is all real because it never stops. It's going to just keep going up a little bit, going to keep going down a little bit, going to continue on forever. It doesn't have a minimum. It didn't vertically shift. It didn't horizontally shift. I'm going to skip stretch and compression real quick. My line of symmetry, it doesn't have any. It's not symmetrical. But as x approaches infinity, what is y approaching? Good. As x is approaching -infinity, what is y approaching? Infinity. Okay, my stretch or compression is kind of how close I am to the graph. In this case, I flipped it. But usually it's going to be like I made it twice as big, or I made it half as big. So we're going to do number 2 to kind of see those differences. Okay, that's stretch and compression. Actually, I think it's going to work better if we look at number 3.
Can we still do number 2?
Yep, you're going to do every single problem.
For compression library, what you
I might not do every single problem, but you're going to do
I know,
it.
but can you go over number 2?
I will. I'll go back to it. Yeah. Okay. So if we're looking at number 3, I'm plugging in these points, and I get 15, 5, -1, -3, -1. Right? So I got 2 and 15 doesn't show up, so I'm going to go 3 gives me 5, 4 gives me -1, 5 gives me -3, 6 gives me -1. So I know I'm going to start going up again, right? Like this. What's my domain going to be, guys? All real numbers. It's going to keep going out and out and out and out as it goes up. Okay? What's my range here?
Y is greater than or equal to -3.
Y is greater than or equal to -3. It can't go below that. There's nothing down here. What's my, do I have a maximum or a minimum? Minimum, and what's my minimum?
5, -3.
Good. What's my vertical shift? Did I go up or down?
Down.
How much? 3. Did I go right or left?
Right.
Right, 5. And remember, I'm thinking of this all from x squared. X squared is like right here, that's my parent function. So it's like what I did to go from there to there. Okay, here's where I'm going to talk about my vertical stretch or compression. Okay, see how wide this orange one is? See how this one is skinnier? I can't, I'm in the middle of this. Okay, so this is like, here is my arms in the air. Okay? It's like somebody grabs my hand and pulls me towards the ceiling. So am I compressing or stretching? Stretching. So we stretched up by 2. Like, seriously. We stretched by 2.
Is it because it's on the outside?
Okay? This is on the outside.
Stretched by 2.
Okay? It's twice as up. Okay? Line of symmetry is still x equals 5. And let's talk about our end behaviors before I go questions after this. As x approaches infinity, y approaches, okay? As x approaches -infinity, y approaches infinity. Yes?
So you know it's stretched by what's on the outside.
Yeah. Okay? The point is I want to see that it's stretched. Yes?
If it was negative, would it be compressed?
Let's look at something like that. So let's look and see if we can find a negative in front. So let's look at 6, because that was a great question. So I'm going to skip all the way over to 6 because Alexis her idea is if it's negative, it's compressed. So let's go through and answer these real quick. If it's 0, it's negative 8. If it's 2, it's negative 6. If it's 4, it's negative 4. If it's 6, it's negative 2. If it's 8, it's 0. I'm going to tell you right now, if it's 10, it's negative 2, just so you get the idea that it looks like this right here. Okay? I didn't plot those points exactly, I just sketched them. Okay. All right. The domain is all real numbers, right? The range is y is less than or equal to 0. Okay. Does it have a minimum or a maximum?
Maximum.
Maximum. And it is 8, 0, correct? That's as tall as it gets. Did it vertically shift? No. Did it horizontally shift?
Yes, right 8.
Yep. Right 8.
You can compress.
Okay. Now let's look at it. This is the absolute value of x. Maybe we should put this in our calculator so we can see the difference. Okay, so if I'm in my calculator, I'm going to hit the absolute value of x. That's my parent function. And then I'm going to add another one. I'm going to add this one. I'm going to say negative 2 absolute value of 0.5, because it's the same as 1/2, x minus 4. Okay, so I'm just going to move this over a little bit so we can see it. All right. It flipped it, but it doesn't look like it did anything else. I'm going to tell you right now, it did stretch it.
Stretch?
It stretched,
How would you know?
okay? Because this 1/2 and this negative 2 kind of changed it a little bit, so it kind of looks like it didn't do anything, okay? But negatives don't make a difference. My line of symmetry is x equals 8. As x approaches infinity, y approaches negative infinity. As x approaches negative infinity, y approaches negative infinity. Okay, so it didn't look like I stretched it at all or compressed it. Let's look at number 5. This is going to be the last one we're going to do, and the rest you guys are going to do.
What's the number? What did it stretch by?
What do you think? Well, it didn't really stretch at all. It kind of flipped it.
Well, then why'd you do
I don't know if it would be stretched or compressed. I would probably circle question mark. I know there's a number in front, but they kind of cancel each other out. It didn't look like it did anything. So let's look at number 5. For number 5, I've got the points 3, 4.5, 6, 4.5, and 3. So I know I'm doing that fast, but remember, you just stick it in your calculator. Okay, we're going like this. Okay. So my domain is all real. Y has to be less than or equal to 6. It has a maximum of 4, 6. What did my vertical shift do?
Up 6.
Up 6. What did my horizontal?
Right 4.
Right 4. Okay. Its line of symmetry is x equals 4, and I know my end behavior is x approaches infinity. What is y approaching? As x is approaching negative infinity, y is approaching. Okay, so let's plug this into the graph, and we should be able to see a better difference here. So I've got negative 3/4 absolute value x minus 4 plus 6. Look at that. Doesn't that look way wider?
Yeah.
That's compression. So it is compression. Okay?
So if it gets wider, it's compressed.
So what changed? What is different between here and here? If I say a number in front stretches it, why did this number compress it? These are both negatives.
Because of the fraction.
Fractions. So fractions compress. Whole numbers.
Stretch.
Fractions compress. Whole numbers. Okay. And remember, compress, I know it looks weird because you think, oh, it's wider. But think about when we sit on a ball. Okay? If you're sitting on like a bouncy ball, like, you know, like one of those yoga balls, or you're sitting on like a ball that you play dodgeball with, when you sit on it, doesn't it go out?
Yeah.
Okay, so compress means wider. Stretch means skinnier. Okay?
What if there's no number?
Then it didn't stretch.
So it's none?
Right. Okay, so I did 5 and 6. You guys are going to do 7, 8. I did 3, 2. So you just have 7, 8, and 2. So you and 4. So you got 4 to do for homework tonight.
Quick question.
Yes.
So for like 7 and 8 with the square root, if there's one at the front of the square root, is that how much is stretched or compressed?
I don't know. Maybe you should put in your calculator or in Desmos.com to find out.